Starting from version 9 of UniFi Network Controller, Ubiquiti supports the so-called zone-based firewall. Just by looking into the even initial matrix, it already looks very overwhelming. Even though the purpose for Ubiquiti to introduce the zone-based firewall is to simplify the firewall settings. In this video, let's look into the backend to understand how the zone-based firewall is implemented. Then you will realize, in fact, from technical perspective, there's nothing new. It is still the old traditional IP table filter implementation. You may know, without using a gateway or router, just by using a standard Linux, you can already implement very complicated firewall rule solutions by using IP tables. In the lower left terminal, let me run iptables command. So you can see basically the IP table rules are classified into 3 blocks, if you will: input, forward, and output. Everything is just one of the 3 blocks. So what's input chain? Input means for the packets whose ultimate destination is the gateway. And what's output chain? Is for the packets which are locally generated from the gateway. The ultimate source is the gateway. Then what's the forward chain for? It's for the packets which are simply being routed through the gateway. So the forward chain is the normal situation when we talk about router, because it needs to route traffic, right? You can see just from IP table perspective, it doesn't really care what's LAN, what's WAN, what's DMZ, what's guest. No, it doesn't mean anything to IP tables. It simply cares, okay, you have a packet. Whether the packet is generated by this Linux machine, or is to this Linux machine, or is simply want to be routed by this Linux machine. So based on the 3 different reasons, the system will use the different chain to handle the packet. That's it. Very simple logic behind IP tables. In the top right, I show you a UniFi gateway which still has the old firmware before the upgrade. So you can see in the old firewall rule setting, the system does have multiple sections for different types of firewall rules: internet, LAN, guest, right? And then for internet, it's furtherly split to internet in, internet local. For LAN, it has LAN in, LAN out. And for guest, it doesn't have further split. Even though this type of grouping or classification, it is facing the end user, still it's pretty technical. For example, many people will be confused what's internet local. For example, people will ask, if I have a firewall rule for my local network, do I put it in LAN in or LAN out, right? So this type of questions are due to the fact that this way of grouping firewall rules are still from the backend technical perspective. So that's why in the new zone-based firewall rule, so in the lower right, you see the upgraded firmware. If you go to security, if you convert your existing firewall rules to the new one, the system introduced 6 so-called zones. In fact, even before the upgrade, look at the old one. The LAN also can be called a zone, right? It's just in the new firmware, LAN is furtherly split to VPN, Hotspot, and DMZ. And then the internet is renamed to external. Guest is renamed to hotspot. Basically, this type of zone settings technically is still the same old way. It's just Ubiquiti gives it a fancy name, and logically a new layer is introduced when you define firewall rules. But as I mentioned, this video will be focusing on the backend. Okay, enough about the front end. Let's go to the SSH session. In my lab environment, I have 3 VLANs defined: default network, VLAN 20, and VLAN 30. Then in the new firewall rule setting, let me assign the VLANs to the corresponding zones. You can see for VPN, I already have a WireGuard defined, so that's why it's automatically included in the VPN zone. Then for Hotspot, let me add VLAN 20. Then for DMZ, let me add VLAN 30. By the way, you can see by default, all your VLANs are included in the internal zone, which is for LAN, right? See what will happen to the internal zone after I click the proceed button. See, it's automatically removed from internal zone and then added to DMZ. Okay, now I already achieved what I want. So basically for the 6 default zones, I have the internal or LAN zone, including default network, external, which is the internet, gateway. I cannot do anything. Basically, it's just gateway, right? The UDM Pro in my case. For VPN, it's automatically maintained because I have WireGuard, so it's included. Later, you will see the tele part will also be automatically included, even though you may not be using it. Then for Hotspot, I manually added VLAN 20. For DMZ, I have VLAN 30. Okay, this is the current situation for the 6 zones. Then in the lower part, 2 SSH sessions, let me SSH to the UDM Pro. To show the firewall rule related IP table entries, let me run this command. I want to see the filter table, which is for firewall rules, and I want to see the verbals, detailed information, so that I can have several more columns to better understand the rules. Then I want to show the line number. Okay, let me run it. So you can see there are a lot of rules. Just to make the navigation easier for this video, let me run the same command but export the result to a file. Then let me use VI to display the file. If you check the UniFi network controller, it shows you the zone matrix for each pair of zone relationship. You can pick a zone as a source and pick another zone as destination. Then you can get the corresponding policies. But this table looks very overwhelming if it's the first time for you to check it. To easily understand it, I prepared multiple breakdowns in the diagram. So from each zone as source, I draw a dedicated diagram so that we can go through them in this video to understand what's the default firewall rules generated for them. So let's start from gateway as the source. So here, gateways as a source is here. And then, for example, if I want to understand gateway to gateway, see from this matrix, it's showing dash here. Why is that? It's simply because we are talking about the same Linux machine to the same Linux machine. It doesn't make sense because we are talking about firewall rule. This type of traffic will not go through the firewall rule. That's why this type of from to relationship doesn't make sense. That's why it's showing dash here, right? Because here we are talking about gateway as the source. Remember I mentioned there are 3 blocks for IP table filter rules: input, output, and forward, right? So from gateway to internal, this type of traffic falls within output because the packet is originated from the gateway itself. So that's why the starting point for me is this chain output. See what's the chain it's using? It's the output jump. So let's search for output jump. Okay, it's defined here. See, it's simply calling another chain. It's called output user hook, and it is showing here. Then it includes multiple chains. So let's understand what they are. See, the first one, local 1 user. See the out interface, Ethernet 9. Because here we are talking about the UDM Pro. Ethernet 9 is port 10 you see in the network controller. Port 10 is the primary one part. Then see the next one is the same chain name, but the out part is Ethernet 8, which is the secondary one part, port 9. Now let's look into the group name. It's called local 1. What Ubiquiti mean by local here? It means gateway, because we are talking about the IP table rules within gateway, right? So to translate this chain name, it is from gateway to 1, which means these two particular chains are talking about this green link from gateway to external, because the internal name for external is 1. Let's look into the local to 1 chain to see what the system will be doing there. So then let me search for local to 1. Okay, it's defined here. It's a super simple chain. It simply accepts everything. It doesn't have any limitation. That's why from the firewall rule, if you check destination external, see the green allow all, right? Then if you click on it, you see one policy. It says allow all traffic. So basically, this particular chain you see in the IP tables is corresponding to what you see on the UI, allow all traffic. I hope you are clear about how to do it step by step. Going forward, I will not start from scratch. For each link, I will simply talk about the effective chain information. About gateway as the source, we are not done yet. Let's continue looking. See, the next one is from local to LAN, which is corresponding to this green link. Gateway internally is called local. Internally is called LAN. So this green link corresponds to this particular chain. So if we search for it, see it's here. Again, it's a super simple chain. It accepts all. Then go back, see the other one. It is local to guest. Guest is the internal name for hotspot. So basically this particular chain is corresponding to this green link. So then we can see what it is. As expected, it's simply accepting all. Then in the same way, from local to DMZ, it's accepting all. Now you may think it's super simple for this gateway as the source situation. We can move on, right? Hold on a second. Let's look at the from gateway to VPN. So from the matrix on UniFi network controller, from gateway to VPN, it's showing here is green allow all, right? But if you check this chain, it is called local VPN, which should be corresponding to this one, right? But the problem is here, it says 0 references, which means it's not used at all. Then let's go back to the parent chain. For this output user hook, it only has local to 1, local to LAN, local to guest, local to DMZ. It doesn't include local to VPN. My theory is here it is a bug from Ubiquiti. Apparently, it missed to include the local to VPN chain here. Okay, so if you think differently, let me know. Now it's time to move on. When the source is internal or LAN, the destination is gateway, it will be a special case. Because if the gateway is the destination, we need to check the input chain instead of forward chain, right? So our starting point will be this one. Then you can see the input jump is defined by this chain, and this chain include multiple subchains, right? The one which is relevant to this yellow link for this scenario is this one, from LAN to local. So let's see how it is defined. First thing may catch your eye is this one. So the input interface need to be BR0. In right side, in another SSH session, let me show you what's BR0. Let me run bridge control command, show the bridges. See the BR0 definition? It includes these interfaces. What's Ethernet 10? That's the port 11 on the UDM Pro, which is the 10 gigabit SFP plus port for LAN. Basically, what BR0 really means is for VLAN 1 for the default network. Because if you check other bridges, let's say BR20, see, just by looking into this naming convention, you can already tell it's for VLAN 20, right? This one, Ethernet 10 without a dot, it is for the default network. It makes sense because as defined in the firewall rule for zones, for internal, we only have one VLAN, which is the default network. So what we see here makes sense, right? Let's continue looking into this particular chain. Okay, it's here. So this one is a little bit complicated. See the first rule, number 1, is accept if the protocol is UDP, and see the last part, it has to match a set. Which set? This set. Match what? Match the source. And then it also need to match another set. And match what? Match the destination. Then it also need to match another destination with this name. So let's look into this set definition. Then we can understand what this rule is really talking about. So in the right side, let me run IP set, then list the particular set name. The set is simply map the part. What's the part? It only includes one member, 5353. And let's check another set, which is for MDNS address name. It's defined using 2 members. Let's check the IPv4 version. It's very simple, just one hard-coded IP address. What this part really is saying is just UDP is not enough. So the source part number need to be 5353. The destination IP address need to be this MDNS IP address. And then the destination part number need to be 5353. Will allow UDP packet if it's for MDNS. Okay, we can confirm that in the zone matrix. See from internal to gateway. So the first policy is allow MDNS. It makes sense. That's exactly what we see from this iptables filter rule. Let's continue to the second rule. Here it says accept all, no any limitation. After reading the second one, you may be confused because if the second one is allow all, what's the point? We have the first one. Right? Here comes a shortcoming of the new zone-based firewall. Ubiquiti also mentioned in its help document that after the automatic conversion of your old firewall rules to the new zone-based firewall, it may end up with some redundant policies, so it won't impact the end result. It's just they are useless, they are redundant. I believe this is one of the situations, because the optimized way is to simply leave the allow all, right? You don't really need the first allow MDNS, but it doesn't impact the final result. Okay, let's move on. All the remaining policies, they are about routing, or to put it another way, it's about the forward chain of iptables. So I will not repeat the process starting from scratch. I will directly show you the corresponding chain information. So from internal to external, the chain name is LAN1 user. Here it is. It includes 2 rules. The first one is to drop the packet if the packet connection tracking state is invalid. So that's why from the network controller, if you check the corresponding policy from internal to external, the first rule is to block invalid traffic, right? So we find the corresponding iptable filter rules. Then the second rule is simply accepting all. So if you look at these 2 rules together, what it really means is if from your local network you want to access internet, normally there's no any limitation, but only if you are not doing something crazy, only if your packet is not in invalid state. That's the only limitation. The system just wants to stay in the safe side. That's what this rule really means. So let's move on. For the hotspot, or internally it's called guest. So let's check LAN guest. It's super simple. It's accept all. Then I will skip LAN DMZ. It's in the same situation, allow all. And for internal to VPN, again, the same situation. So I will simply skip them. Okay, then we are done with the scenario where the source is internal. So we can move on. Let's see what if the source is external from internet. Let's start from external to gateway. So because the ultimate destination is gateway, it will fall within the input chain in iptables, right? I will skip the steps. I will directly show you the chain name. External is called 1 and gateway is called local. So that's why the chain name is from 1 to local. Let me search for it. This chain is called from the input user hook. See what's the input interface? It is Ethernet 9, which is one of the one part. And the next one, Ethernet 8, another one part. So this same chain will apply to both one parts. Let's check its details. There are 4 rules within it. The first one, accept anything only if the connection tracking state is related or established. So if you go to the UI from external to gateway, click on it, only show the IPv4 ones. So you see 4 policies here as well. So the first one is called allow return traffic. It's the same thing as what we see in the backend because return traffic means it's related or established. Continue. The second rule is to drop everything if the connection tracking state is invalid. See what's shown on the UI is block invalid traffic. Makes sense, right? Then the third one is to allow UDP packet if, see, this is a new thing, if the destination is WireGuard ports. So in right side, let me show you the IP set information. It's simply defining a port number 51821. On the UI, see the third policy is called allow WireGuard VPN. And if you check the details, basically it's the same thing. If the destination port is this one, right? That's how it's defined in backend. So by allowing WireGuard's port number, the system allows the traffic from internet if it's for WireGuard. The last rule is drop all. If you check the UI, yes, it's block all traffic. That's the very last rule because we are talking about from internet to the gateway. That's the part most possibly to be attacked by external hacker. So of course, the very last rule should be block all. Okay, so we are good about this link from external to gateway, right? So now let's check this particular one from external to itself. This type of traffic is not targeted to gateway. It's not from gateway. It only passes through gateway, right? So I expect to find this one in the forward chain of IP table. So I already know down the chain name. So let's look into it. In fact, this chain is the entry point for most of the links for this scenario. Let's check how it's implemented. So first, it will run this chain. We will talk about this later. Another one from WAN to guest, and then from WAN to LAN, from WAN to VPN. See all the 4 preceding chains, they have nothing from what we want to check from 1 to 1, right? However, if I search 1, 1, I do get a hit. See, the chain does exist. However, there's no reference to it. I think I just found another bug from Ubiquiti. The Ubiquiti should have included this particular chain in the WAN in user chain. Instead, the execution stop here at VPN. Then it will use these 2 rules instead. If you compare these 2 rules with what we see on the UI from external to external, they don't really match. But if you compare this chain, which is not used, it matches perfectly with what's mentioned on the UI. That's why I think there's another bug from Ubiquiti here. So move on to the 4 much easier one because we already see them in the WAN in chain. Before checking the individual subchain, let's try to understand the match set first. See here, for each different branch, it uses different destination IP set. For example, the 1 to DMZ chain will be executed only if the destination meet this IP set requirement. So then in the right side, let's try to understand what's defined for DMZ. So let's check the IPv4 version. It's very easy. Only include one subnet, the 30 subnet. Remember in UniFi Network Controller, we defined for DMZ zone, we want to include VLAN 30, right? That's why you see this here. Only if the destination is in DMZ subnet, the system will execute this chain, right? The logic is similar for the guest, LAN, and the VPN. In the interest of time, I won't show you the details. So even from the diagram, you can see they have the exact same initial policies. So let's take an example. Pick the first one, from WAN to DMZ. On the UI, let me show you from external to DMZ. Okay, 3 rules. So the first one, accept everything if the connection state is related or established. So on the UI, you see allow return traffic. Then the second rule is drop all if the connection state is invalid. On the UI, you see block invalid. Then the third rule is drop everything. On the UI, you see block all. Right? So they match exactly. For all other links in this scenario, they have the same situation. I will simply skip them. Okay, so we are done with this scenario if the source is external. Okay, we already talked about 3 scenarios in very detailed way. I will quickly go through the remaining 3. For this scenario, if the source is VPN, from the UI you can see they are almost all green. Only the VPN to external is showing some policies, right? We can quickly validate some of them in backend. For example, this particular one, from VPN to VPN. See, this is the corresponding chain. It's simply accept all, right? Then let's check this particular one, from VPN to internet. The first rule is to drop all if the connection tracking state is invalid. If we check the policy on the UI, see the first policy is block invalid traffic, right? Then the second rule is accept all, just like what we see on the UI. The front end match the back end perfectly. There's one last thing I want to show you regarding VPN, which is how the system even knows the source is VPN. So let me use this one as example, from VPN to gateway. Of course, the chain name is VPN local, right? But if you check where these 2 chains are called, it's within the input user hook chain, right? And what I want to mention is the input interface. Only if the input interface is teleport or WireGuard, the system will go through this link. Right? So that's how the system differentiates whether the source is VPN or not, by checking the input chain. As I mentioned in the beginning, even though on the UI for VPN, it only lists the WireGuard, but internally, teleport is considered anyways. Of course, if you add other VPN configurations in the backend in iptables, you may see other VPN input source. Okay, let's move on. If the source is Hotspot. So Hotspot is just a fancy name for what we already had in the firewall. The old name is simply guest. So you can see the guest or hotspot's access is very, very limited. It almost cannot do anything. That's exactly what we expect. So let's check some of them. At least from hotspot to external or to internet, no lots of limitations. So let's check it. It's a pretty complicated chain. There are totally 8 rules. So the first one, accept TCP if it's for DNS. Then the second, accept UDP if it's for DNS. See, these 2 rules also exist on the UI. See the very first one, allow public DNS. And the protocol is TCP UDP, right? So let's move on. The rule 3 is accept anything if the destination match the guest portal address. In the right side, let's see what's the guest portal address in my case. Let me run ipset, list this ipset, and drill down to the IPv4 set. Okay, it's very simple. Because I'm using UDM Pro in this live environment, so of course the guest portal runs on the UDM Pro and it has this IP address, right? And similarly, we can check the port number. Guest portal uses these 2 port number. So we are good about this third one. Let's see how it's represented on the front end. It allows hotspot portal authentication. The next rule is to accept TCP connection if the destination is HTTPS and if it's trying to access captive portal. Then move on. See the rule number 5. It will drop the traffic if the destination is guest restricted. So let's try to understand what's this guest restricted. See, it restricted this multicast subnet and the LAN subnets. So basically what this rule is really saying is for guest, by default, it cannot access other internal LAN machines. Okay, then see the next one. It will jump to another chain to see whether the guest is authorized. So this is interesting. Let's try to see what's inside this subchain. So basically it will accept everything if the source is authorized. So let's see what's inside this IP set. At this moment, I have 0 entry because I don't have a guest machine which log on to the captive portal and try to get authenticated, right? So that's why for now, this IP set has 0 entry. But think about it, if you have any guest machine which gets authenticated, the MAC address will be added to this IP set. That's how the guest authentication works, right? So we are good. Go back to the guest 1 chain. We just talked about this subchain and then see what's next. It will drop all if the connection tracking state is invalid, then accept all. If you check the front end, it matches what we see in backend perfectly. Okay, I just want to use this example, and in the interest of time, we won't go through the other. So let's check the guest DMZ one at least. From Hotspot to DMZ, if I show you what we have from the front end, it says allow public DNS. Yes, that's exactly what we see here. Then it will block the post authorization, and then the very last rule is block all. Okay, that's from guest to DMZ, how the firewall rules are implemented. Then let's check the next scenario. If the source is DMZ, because of the nature of the zone is DMZ, there are a lot of restrictions. Let's check from DMZ to gateway first. So from the UI, you can see it's another very complicated set of policies. So it will allow MDNS, DNS, ICMP, DHCP, and allow return traffic. And correspondingly, from the backend in iptables, you can see the accept chain, right? They are all restricted using IP set. I won't show you the details because they work in the same way as we already discussed for other scenarios. At the end, it's a drop all. Of course, because it's DMZ, we don't want to give it a lot of access when it comes to gateway, right? So then let's check another example one from DMZ to DMZ. It's very simple. It's drop all. Due to the nature of DMZ zone, of course, you don't want the machines within DMZ to access each other. Okay, so this is a super long video. I just want to show you, even though from the front-end perspective, the firewall rule setting is changed dramatically, but from backend, there's almost nothing new. It's still the old working IP table rules. Okay, thanks for watching.